The four other LEDs are connected to GPIOs. So GPIO is a general purpose input or output, so it's a type of pin found on an integrated circuit that does not have any specific function. So the function of the GPIO pin is customizable and can be controlled by software. So you can set a GPIO to be input or output, and some GPIO pins may directly support protocols like serial communication and PWM and PCM. So, and it's typically a digital input, so they can only have support. They only support high or low on or off levels. So here is the schematic of the LEDs connected to the GPIO of the C5515EZ DSP. So we have GPIO from 14 to 17, and then we have our LEDs. And here also we can see the GPIO 14 to 17. So we have this. This is our microprocessor. So the GPIO peripheral on this C5515 provides general purpose pins that can be configured as inputs or outputs. So this is the GPIO. When configured as an output, then you can write to an internal register to control the state driven on the output pin. When configured as an input, you can detect the state of the input. So there is 16-bit general purpose IOs that can be individually programmed as input or output with some interrupt capability. This device uses two registers for controlling whether the GPIO is set as a general purpose input or output. So these are the GPIO direction registers, so IO DIR1 and IO DIR2. So writing 1 to those bits configures the pin as an output, and writing 0 configures the pin as an input. So this device includes two registers for writing the GPIO pins when they are configured as outputs. So the data out registers, so IO out data 1 and IO out data 2, they are used to change the state of the corresponding GPIO pin. So we have here all the registers that are related to the GPIO. They have their hexadecimal address range, and here we have the acronym for the for these registers. In our example, we are going to use these functions from this file here to set the direction of the GPIO. So we pass the number of the GPIO and the direction. So here it will detect which register to write, if it's DIR 0 or DIR 1, and then it will set if it's if the GPIO should be an input or if it should be an output. And we can also if it's an output, we can set the output to be a 0 or a 1. So it's the same principle. We pass the number of the GPIO, and we set if it should be 0 or if it should be 1. So I'm here on Code Composer Studio, and I am inside this file that we are going to use in our example. So this is a function to initialize the LEDs. So we are using this GPIO set direction. We give the number of the GPIO, and here we have the GPIO out. So the GPIO to be out, it's declared as a 1 and in as a 0. Then if we go to see, we see this GPIO set direction, what we've seen before. So it's a number, it will check the bank ID. Depending on the bank ID, it will write on the register 0 or 1, and we have here the register is defined. We are going to talk about this volatile IO port this later, but this is we're passing some addresses of the register, and here the GPIO in, it's 0 if it's an in, and 1 if it's an output. So this way here we can set the direction of the GPIO, and we also have this set output. The principle is the same. It will check the bank, so which register we are going to write, and it's also here. So these are the, according to that table, what we've seen before. And here we have to set the either 0 to low and 1 to high, and this way we can set the GPIO output.